Everyone, welcome to Master the Codes, and today we are going to take another important question related to Amazon interviews, that is the binary tree. I will explain two approaches. First one is a DFS approach and second one is a BFS approach. So please do not forget to like, share and subscribe to the channel for more notifications. Without further wait, let's get started. So here's the question which we are going to solve today, that is diameter of a binary tree. Although it is marked as easy, it is not an easy question and is quite commonly asked in an interviews in the companies like Amazon, Facebook, Microsoft, TCS, and many more. This is one of the standard questions. So now let us ace this particular question and so on the coding interviews. But before that, please do not forget to like, share, and subscribe to the channel. Now let's move forward. Given the root of a binary tree, return the length of the diameter of a tree. Okay. Now, first thing is we are given a binary tree, so we are either gonna have no children, or we are gonna have one children, or we are gonna have two children as the root from the root nodes or any other node. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. So it's clearly mentioned in the question. The length of a path between two nodes is represented by the number of edges between them. So if I'm taking this particular path, if the number of nodes are 4, the edges will be 4 minus 1. That is what it is. Now coming to the question, the root is 1, 2, 3, 4, 5. The output is 3. And 3 is the length of the path. Either it is 4, 2, 1, 3 or 5, 2, 1, 3. That is one and the same thing. Now let's move on to the first approach. I have solved this using two approaches. You can take any of them, right? So I'm taking the first approach and then we are gonna go for the second approach as well. Okay, so here's the question for today, which is diameter of the tree, in which, as per the question we are given, we have to find the two root nodes in the tree. The nodes should exist in the tree such that the distance between them is maximum, and that can be termed as the diameter of the tree. As you can see over here, diameter is the maximum distance between any two nodes in a tree. So if I take these two nodes, the diameter is 1. If I take these two nodes, the diameter is 2. And if I'm taking these two nodes, the diameter is 5. Right? So clearly you can see these two nodes are giving me the maximum diameter, or even these two nodes are also giving me the maximum diameter, and the diameter is passing through the root, right, the head node. But if you look at this case, in this particular case, the maximum diameter, if you can see it visually, is this, and it is not passing through the root. So the diameter may not necessarily pass through the roots. That is one thing, right? So in this particular case, we need a unique approach, because in tree, right, so this is the root, and in a tree the root is the starting point, and then from root the various branches are formed, which are termed as either the children or the intermediate nodes, and then from root it goes down to the leaf node. So clearly you can see the diameter may not pass through the root, and in tree you do not have predefined parents, right? You're not given the parents, right? From root you can go to the children, like you can go this way, but going in the opposite direction is not possible in a tree. So in that case, what do we need to do? If I take this particular test case, the diameter is 5. I have taken this case only, right? So we need to apply recursion and DFS in this particular question. So how we'll do it? let's we so first look at this particular tree, right? Look at this particular tree. Clearly this node does not have any children, so they both correspond to null. This node, whenever you are doing DFS algorithm, or if you don't know the DFS algorithm, I'll provide the link in the description, you can have a look at there. Whenever you are doing a DFS algorithm, whatever you are passing in the during the recursive call, that will be sent back to the previous call, right? So
whatever you're passing, whatever the output is coming in 8, that will be passed to 5. 5 will pass it to 3, and 3 will pass it to 2, and then back to root 1. That is how the recursion works. Now, if you look at this particular case, this one, you have the depth as 1 over here because there's only one node. I'm just talking about this particular branch. And now if you look at this particular branch, the depth is 2. And if you look at this particular branch, the depth is 3. So what is happening whenever you are doing a post order DFS, we can just pass the depth of the current node to its previous node and increment it by 1, right? And similarly, if you look at this particular case, it has a depth of 1. But if you look at this particular case, it has a depth of 2. So what are the options we have? Clearly you can see this particular branch has a higher number of nodes as compared to this particular branch, right? So what are the options? Either we can choose a left branch, or we can choose a right branch, or we can choose both the branches. Now why I'm saying both the branches? If you look at this particular test case, I'm taking the sum of both the branches. I'm not only going to left, I'm not only going to right, I'm taking both. So that is one way which you can do. Now these are the options. Either you choose a left, either you choose a right, or choose both and left and right and decrement by -1. Because if you are doing this 3 and you are adding 2, this particular node is getting added twice. So you need to decrement it by 1. Now if you look at this particular case, here corresponds to the left, right, and the center, or rather the left plus right, correct? So if this particular node given, the left child is 0, the right child is 0, and if you add the current node, it is 1. Now this particular 1 will be passed to the previous or the ancestor node, not the ancestor, rather the parent node. Now if you look at this, the left child has a size of 1, the right child has a size of 0, and the current will be 1 plus 1, 2, right? Similarly, if in this case the left child has a depth of 0, right child has a depth of 0, and the current has a depth of 1. Now if you look over this particular case, the left child has a depth of 2, got from here, and right child has a depth of 1, got from here. And if you add them, 2 plus 1 3 and plus 1 4, that is the depth which you are getting, right? Total 4 nodes. Similarly, this particular case has a depth of only 1. This particular case has a depth of 2, where right child has a depth of 1 and the current node has a depth of 2. And similarly for here, we will check the left, which is 3, right? The right, which is 2, and the center, which is 3 plus 2 plus 1. 3 plus 2 plus 1. Similarly, this will be passed to the above, the final root. The answer 4, with the left child as 0 and current child as 6. So similarly, when this DFS ends on the root node, the depth will be provided to us as an answer along with the diameter. Now what we need to do, we need to start from the root. Used post order to store the maximum depth, right? And now why we are doing this, why we are doing post order? Because going from parent to child is difficult because you don't know how many children are there. If I hide this particular tree and I'm just looking at this node, you can't count. But if I'm looking at this particular node, you obviously know how many parents are up there. So that is why we need a post order. Now, what is the second approach? That I'll discuss in the next video. So first, let us go to the code of the first approach, and then I'll discuss the second approach.
So here is the code. I'll explain the code line by line, but first let us see how the execution works. I have created 6 nodes. The first node is connected with 2 and 3. then 2 is connected with 4 and 5, and 3 is connected with 6, right? So now I'll start with the code. Currently given the diameter, here are the parameters that are going to change, right? Currently the diameter is 0. Then it goes to another node, the next line. The left child are 2 and 3. As the 1 is the root, the left children are 2 and 3. Then the left depths and right depths are 0. Then we'll go to the left subtree of 2. And the 2 has childs of 4 and 5. And if the child doesn't have any left depth, we are not going to check. Then we are now at node 4, right? We are now at node 4. If I print the root as well, we are now at node 4. Uh, okay. Now node 4 doesn't have any children because left child is -1 and right child is -1. So it will return 1. Okay, now from here we go to node 2. Node 2 has the right child of 5. So it will recurse again. Now we are node 5, which have left and right child is -1, and we'll get 1 as an answer. So node 4 will return 1 and node 5 will also return 1. Now we'll go to the diameter part. Diameter will be the maximum of diameter, that is 0, plus 1 and 1, that is 2. So diameter will get updated to 2. And then we'll return the maximum of left depth or right depth plus 1. Either we are taking the left or we are taking the right and adding the current node as well. So that is why we are doing a plus 1. Right. Now from the right child, we go to the right depth. The current node is 1. Now we go to the node 3. Left child is 6 and right child is -1. That means the 3 has only a left child of 6. Okay. Now we go to the left depth and the right depth, and again we go to the left subtree, that is node 6. And from node 6 we'll return 1 because it is the leaf node. Now this particular left depth is 1 and right depth is 0 automatically. So the diameter will be the maximum of both of them. And so we'll return 2 only, and the left depth will become 2 and right depth will remain 0. Then we come to the node 1, and from node 1 we have evaluated 2 and 3 subtree. So now we'll go to the root node, and hence we get the diameter as 4. That is how the DFS algorithm will work, and if you look, you can have the tree structure here as well. This is one of the basic, or rather the most normal approach, standard approach for evaluating depth of a tree or diameter of a tree, in which we have a left child and the right child. We check if it is a leaf node. If it is a leaf node, we return -1 or rather a 1. Then we set the left depth and the right depth. We recurse for the left subtree and we recurse for the right subtree. And we take the diameter as the global. Since we want to find diameter for the entire tree and not for any node. So that is why we take diameter global. And we perform this operation, either take the maximum of the current diameter or the left and right depth summation. And similarly, we either take the left or right depth for the subtree and add +1 to count the current node itself. In the next part of the video, we'll move to the second approach, that is a 2-pass DFS. I'll explain it in a similar way, but please don't forget to like, share, subscribe to the channel, and hit the bell icon for more notifications. Until then, bye bye.